Yeah, hi, this is Dr. Satish. In the previous class, we started with the linear equations in two variables. I told you we talked about the linear equation and some important definitions also. And we have seen that we can solve the linear equations in two variables by using any graphical method or any simultaneous equation approach. So before we proceed into that, in the examination they'll be asking about the conditions to be satisfied, whether the linear equations are parallel or coincident or they are intersecting. Okay, so for that let us take up two simultaneous equations or two linear equations like this. Two linear equations. Okay, say it as a1x plus b1y plus c1 equal to 0. This is one equation. Other equation is a2x plus b2y plus c2. So what I have taken two equations, two linear equations or two simultaneous equations. Okay. Now I would like to tell you that there are certain conditions to be satisfied by the equation. From the equations we can say that these two equations are coincident or they intersect or they are parallel lines or they are consistent or not, like that. Okay, so for that thing, what is that? The first condition is that suppose you test it. If a1 by a2, okay, is not equal to b1 by b2, okay, we say that it has at least one solution. Okay, at least it has one solution. So what does it mean? It means that both these lines, they intersect each other. So once again I am drawing it here. That means both these lines, they intersect at say one single point. So I told you what is meant by a solution. Okay, solution means the value of x and y should satisfy that particular equation. Okay, so this is the point, the value of x and y, which these two lines, they intersect at one point. So that is, so they are intersecting at one point. We have only one solution. So we call them we call the system as consistent system. Consistent system. Hope you understood. Okay. The second case is that suppose a1 by a2 is equal to b1 by b2, which is equal to c1 by c2. So all these variables already I have told you, a1, b1 are the coefficients, real coefficients of x and y. c1, c2 are the constants in a linear equation. Okay, so we are trying to find out the conditions such that in the examination, if they ask you, they have given you two equations in the objective type. Okay, and they ask you whether these two equations are coincident or consistent or intersect each other or parallel or coincident, something like that. You can, or how many solutions they have. Okay, so like that you have to use these conditions in order to solve those kind of problems. So in the second case, we are saying that a1 by a2 is equal to b1 by b2 is equal to c1 by c2. So for this case, there will be infinite number of solutions. There will be infinite number of solutions. So n number of solutions we have. This condition is satisfied. Okay, what does it mean? It means that they are coincident. Okay, that means I'll draw it here. So there are two lines here, as I told you. Another line will be on the same line. I'm just marking with like this. They are coincident. So n number of points, n number of solutions can have. N number of solutions can have. N number of solutions. Both the lines are on the same line. Okay. So they are consistent. This system is also consistent and dependent. So dependent means n number of solutions we can have. Independent means only one solution. Okay.